Hello friends, in my this video I am going to discuss one MATLAB CODY problem and it is problem number 497. Make an awesome ramp for the tiny motorcycle stuntman. Okay, this is the problem statement and what it says that given a vector say v equal to 1 3 6 9 11, turn it into a matrix ramp like so. So see here this kind of matrix is given. Okay, so m equal to 1 3 6 9 11, then 3 6 9 11 0 6 9 11 0 0, like that it will go. See, ramp type functions it is generated. I am going to show you the normal code. You can implement the same program like one function also. Okay, and this ramp type matrix you have to make. That's way a tiny motorcycle stuntman can follow the trace and jump over 9 school buses safely. This is just for fun purpose, it is written anyway. Our programming interest is how we can generate for this particular matrix from this particular array. Okay, this array is given input by the user. Now you just try to understand. You just consider the second row of this particular matrix. So before that, just observe one important property of this particular matrix. This is suppose you take transpose, then also you will get the same matrix. Just you observe. Just if you take transpose, that is make rows to column, column to rows, you will get the same matrix 1 3 6 9 11, then 3 6 9 11, then 6 9 11, then 9 11 11, rest all are zeros. Okay, this is one important point, interesting property of this particular matrix. And you just observe the second row, what is happening. Suppose this second row is another array. Okay, this is our first row which we already have from input user, which we already have from the input which is given by the user. And if you want to make this second array, what you can do, see this for this second array, the first element start from the second element of the first array and it goes up to the end, and later 1 0 is added. Okay, so this algorithm we can use to make the second array. Let me show you how we can do. So x equal to input, first enter the array. Okay, we are taking input from the user. So before that, if you want, you can write clc clear all and close all. Okay, now you define one empty array. We'll store here. So let me define L equal to length of x. Okay, then see for I equal to 2 colon length of x, what is happening? Simply second array elements are the first array elements starting from second position to end, right? Now see what is happening. You just consider any particular row. Suppose you consider the second row and third row. See, for third row, the first element starts from the second element of the second row, right? And see, zeros has to be printed in rest cases. Okay, so what we can do, we can write here I equal to 2 colon length of. Okay, then here you can define another variable. Suppose u equal to length of y, that is up to here we formed. Then you can use another for I equal to u colon our original length, that is L. So basically see up to length of y it is already, so if you length length of y, so up to length of y already element is there. So basically it will start from u plus 1. So for I equal to u plus 1 to length of L, you will store 0. Okay, let us check whether our code working or not. Suppose let me give enter the array 1 2 3 4 5. Length spelling mistake, sorry, this will be in small letter. Okay, so control A, evaluate selection 1 2 3 4 5 and enter y equal to, sorry, here equal to sign will be there. Control A, evaluate selection, then 1 2 3 4 5. Now if you check, write y, enter. See 2 3 5 2 2 3 4 5 0. Okay, so see we achieved our particular aim. That's what we want to generate, right? So basically now what we can do, we can implement this code as a function and we can call it recursively. So see, here I have made one function ci where z equal to length of x, y equal to define one empty array. For I equal to 2 colon length of x, y equal to y x of I n, c equal to length of I. For I equal to length of y plus 1, or here you can write c plus 1 to z, y equal to y0 in this for loop, and one more n for this particular function ci. Okay, now we can call this function recursively and we can write our code. So see, here I have written the main body, CLC clear all, close all, warning of these things you can write. Then x equal to input, enter the array. Then r equal to length of x, z equal to define one empty array, and z equal to z and x transpose. Why? If you observe this particular matrix, this particular input is directly using in the first column. So we are first inserting the first column. So remaining 4 columns in the 5 input array. So 4 columns means 5 minus 1. Similarly, in general, for I equal to 1 colon length of x minus 1, it will go x equal to ci of x. So we are calling the function, will perform the certain task, and we will again insert in our empty array, which is defined here z. Okay, so at the end of the execution, the target matrix will be stored in z variable. So let us check. So let us give the input given by the code itself, 1 3 6 9 11. So 1 3 6 9 11, you write enter, you write z and enter. See what you are getting. See, 11 is making one lamp here. You just observe here, 11 is making one lamp, right? And you can check for some more cases also. Suppose let me give 7 8 9 4 5 6 1 2. See, you write z. Let me make comment a little bit bigger. You write z and enter. See, here also you are getting one ramp of 2. Okay, see, 2 2 2 2, and here 7 8 9 in the first row, 7 8 9 4 5 6 1 2. Then in the second row, 8 9 4 5 6 1 2, then 0 is inserted. Like that it will go on. Okay, so this concept you can implement if you already have seen my previous video where I explained column circulant matrix in detail. There, this kind of concept only used. By modifying that code a bit, you can write this code also. Okay, so that's what I have done here also. If you check my previous video, you can clearly understand. So if you want to check the column circulant matrix video, please go through the link given in the description. Okay, I'll post the 2 codes in the description of this video. If you have any doubt, you can ask in the comment section. Thank you for watching.